Hello everyone, my name is Jared, and today I will show you this Physics 161 problem. This is number 3 from midterm 2 of fall 2006. So, a planet X has surface gravity Gx is equal to 3.5 meters per second squared. It has a giant ice-covered volcano whose vertical height is equal to the radius of the planet Rx is equal to 5.3 times 10 to the 6 meters, and whose slope is 70 degrees. A space sled slides from the top of the mountains. Find its speed at the bottom if we neglect air resistance and friction. You do not need to know g or the mass of the planet in this problem. So first, to solve this, we want to write the knowns. We know that gx is equal to 3.5 meters per second squared, and rx is equal to 5.3 times 10 to the 6 meters, and that theta is equal to 70 degrees. And what we want to solve for is the final velocity at the bottom of the mountain, Vf, and that's going to be in meters per second. Now we should assume no air resistance and no friction from the problem. So the best way to go about this first is to draw a diagram. You see this is what the original problem had. But I labeled the states at the top of the mountain, labeled it 1, and at the bottom of the mountain 2. So when the sled starts at the top of the mountain, it only has potential energy. So it's going to just have U in its component. But when it's going down the mountain, it's going to have both U and K, because U is the component made up of the radius of the planet, and K is the kinetic energy it builds up as it goes down the mountain. So since we can ignore air resistance and friction, we can say that the initial energy is equal to the final energy. And using the gravitational energy equation, we can get negative G times big M times little m over r is equal to negative G times big M times little m over r plus 1/2 mv squared. And then substituting for the necessary variables in this problem, we get this expression. So to go about this next, we can use Newton's second law to say that F is equal to ma, but we can also rewrite it as F is equal to mg if it's going downwards. And we already know g, so we can use the gravitational force equation to write out the g times the mass of the planet times the mass of the sled over the radius of the planet squared is equal to the mass of the sled times the gravity of the planet, and this is occurring at state 2 over here. So if we set our two unknown variables, g and big M, equal to what we already know, gx and rx squared, we can substitute it into this equation, and then we can get this new expression, which when simplified down and canceling out some of our unknown variables, we can get negative gx times rx over 2 is equal to negative gx times rx plus 1/2 vf squared. And then if we isolate vf, it actually is equal to the square root of gx times rx. And plugging in the values we already knew, we can get that the final velocity is equal to 4,307 meters per second. Thank you.